Alright guys, we are going to be learning about enzymes and activation energy today. So I thought it would be cool if I did a video for you guys so I could help you learn a little bit more about activation energy. So I wanted to go over a little bit of a recap before we get into activation energy. So from our videos and what you should have learned about, you will remember that your enzymes look a little like a Pac-Man, right? So right here, you have your enzymes. Remember, your enzyme is a type of protein. It's a type of protein that speeds up chemical reactions. And they're really important for a lot of biological processes that occurs in our bodies. Reactions. So throughout this lesson, I'm going to be abbreviating reactions as RxNS. Okay? So here we have our enzyme. You'll notice that an enzyme has to act on a molecule. So we called this molecule a substrate. A substrate, it's just another name for a molecule. So remember, we're speaking in enzyme language right now. We're going to be using a lot of scientific language. So a substrate is just another name for a molecule. Okay. So you'll see that the substrate will come in here and fit in perfectly. So we'll notice that the place where the substrate fits in is called let me do that in a different color, it is called a active site. Okay, so this is where the substrate will bind, and the enzyme will do its magic. Okay, so that's a little bit of a recap that I wanted you guys to know. These are the key things I want you to know about enzymes. Well, let's pick a different color. So today, our key question here is how do enzymes speed up the reaction? How does that even happen? So let's go on over here. So you're going to see this graph. This is a common graph that is often used when looking at activation energy. So let's dissect this graph a little bit. Okay, I'm going to make it a little bigger. So first, let's label our x-axis and our y-axis. So we see here on our x-axis, we have something called reaction progress. This is just what is happening in the reaction. What is happening in the reaction? Okay. Then here on our y-axis, we have something called Gibbs free energy. I don't need you to know who Gibbs is. You don't need to know that the energy is free. All I want you to know is this is the energy of a reaction. Remember from our ATP lesson, energy is literally everything. The body just needs so much energy. So let's look at different parts. You don't need to know what delta G is. Cross that out. So here you'll see, let's use a different color. Let's go with pink. You'll see here you have reactants and you have products. Remember, a chemical reaction always starts with our reactants and we go to our products. So our enzyme is going to act right there. Okay? So we'll see here that our reactants start at an energy that is higher than the products. So our products energy is all the way down here. Remember, we start at 0 right here, and it increases going up. So we'll see that our reactants are higher up than our products. So let's add that little tidbit right here. So the reactants energy is higher than the products. Okay, so now let's truly understand what this graph is trying to tell us. So you'll see something funny here. E of A. What is E of A? E of A is just activation energy. It's just a shortened way to write activation energy. What exactly is activation energy? Activation energy is the energy needed to make the reaction happen. So you'll notice here, this is how much energy is needed to make the reaction happen. So our activation energy is going to be how much extra energy we need to put in order to get our products. Okay? So our activation energy here is pretty much this amount. So our reactants are already at this energy. We need to get our reaction to reach this much energy in order for it to become our products. And that's what this graph is telling you. Now, let's go down a little bit. Let's go down right here. So let's look at what happens to the reaction when we have no enzyme and we have a enzyme. So let me highlight that for you. So activation energy without the enzyme and activation energy with the enzyme. So remember here, let's label our axes. We have our x-axis right here, and we have our y-axis right here. So you'll notice your reactants start right there, your products end right there. Okay? So now you'll see that the activation energy without the enzyme is about that much. And then the activation energy with the enzyme is about that much. So which one is lower? If you said with the enzyme, you are correct. So the activation energy with the enzyme is going to be lower. Lower. With the enzyme. And I want you to think about why this is so important. Let me give you an example of why this might be important in our real everyday life. Let's say you are going to bake something, right? Let's say you have an oven. Let me make that bigger. You have an oven, right? Oven shaped like that. You have your little top right here. Your stove, and you have your oven right here. What is usually the first thing you have to do to your oven? You got your little light in the oven. Okay, and we have our little whatever is baking. Okay, the first thing you usually have to do is preheat your oven. Preheat your oven. Let's say we have to heat it up to 375 degrees Fahrenheit. Usually this takes about 10 minutes. Okay, this usually takes about 10 minutes. What if you had a way to get rid of this 10 minutes? And your oven automatically was at 375 degrees Celsius. You didn't even have to wait those 10 minutes. 375 degrees Fahrenheit. You don't even have to wait those 10 minutes. Well, that's exactly what an enzyme would do. An enzyme would make that already happen. And so what you end up doing is you end up, conserve a lot of energy, because you don't have to put in that extra energy to make the reaction happen. And 2, you actually save time. You save a lot of time. Okay? So that is why enzymes are really important. They automatically make a lot of these reactions happen quickly by decreasing your activation energy. So let's go through some key points here. Okay, we are almost done. The first one, E of A, stands for activation energy. And this is the energy needed to make the reaction happen. Enzymes, so let's do a different color. Let's go with red. Enzymes decrease activation energy. Enzymes decrease activation energy. And they make the reaction happen a lot faster. Reaction happen faster. And that is all we have for enzymes and activation energy.